A single 24 megawatt data center can cost roughly $240 million before the first customer moves in. It may employ fewer people than a busy supermarket. It may have no attractive storefront, no passing customers, and no product you can hold. Yet, once it is full, our illustrative facility can produce almost $48 million a year before reimbursed electricity. So what exactly is the owner selling? Not artificial intelligence. Not cloud software. Not even the servers. The product is a promise. This exact block of electrical capacity will remain available, cooled, connected and protected every second of the year. A tenant brings in racks worth millions. The owner supplies the concrete shell, substation, generators, cooling loops, fiber routes, security and technicians that keep those racks alive. AI has made that promise unusually valuable. The International Energy Agency reported that data center electricity demand rose 17% in 2025. Capital spending by 5 large technology companies passed $400 billion and was expected to climb sharply again in 2026. But a boom in demand does not guarantee a good building. Construction cash leaves years before stabilized rent arrives. Power can be promised before it is available. A single customer may fill an entire hall, then use that leverage to negotiate the price down. And the equipment that protects uptime begins aging the day it is switched on. We will build one 24 megawatt wholesale colocation facility from the utility feed down. Then we will follow every dollar through rent, operating costs, replacement capital and debt. At the end, the same building will produce one of 3 results: a cash loss of almost $6 million, a base owner's cut of about $13 million, or a strong case surplus above $28 million. The difference begins with understanding what the owner actually owns. When people say data center, they often combine 3 different businesses. The first owns the powered building. It develops the site, secures a utility allocation, builds redundant electrical and cooling systems, and leases usable capacity. That is the business in our model. The second operates infrastructure services. It may sell cross-connects, monitor equipment, provide technicians on demand and manage customer networks. These services can deepen relationships and add revenue without requiring another building. The third owns the computing hardware. A cloud company, enterprise or AI provider buys servers, GPUs and storage, then sells computing output to its own customers. All 3 can sit in the same room, but the economics are not interchangeable. If the price of AI compute doubles, the building owner does not automatically receive that upside. If a tenant's new chips become obsolete, the building owner may still collect rent unless the tenant fails or leaves. This distinction prevents the most common mistake in data center economics: counting the value of the servers as part of the landlord's investment, then counting the tenant's cloud revenue as the landlord's sales. Our owner supplies 24 megawatts of commissioned critical load. That means power usable by customer IT equipment after accounting for the supporting systems around it. The utility connection must be larger because chillers, pumps, fans, lighting and electrical losses consume power too. Customers lease large blocks of that critical capacity. Rent is quoted in dollars per kilowatt per month. A 1 megawatt customer is therefore not merely renting floor space. It is reserving 1000 kilowatts of continuous, engineered capability. This is why a data center is closer to an airport gate than a warehouse. The floor matters, but the scarce product is permission to operate through a constrained system. And before that system can earn $1, the owner must secure its hardest input. Land is visible. Power is not. A developer can buy a large parcel near fiber routes and still own a field that cannot support a data center. The utility must confirm that transmission, substations and local distribution can deliver the required load. New lines, transformers and generation may take years. In crowded markets, the queue for power can be more valuable than the dirt itself. The U.S. Energy Information Administration says large computing facilities are a major driver of renewed electricity demand growth. After years of nearly flat consumption, grid operators are planning around loads that can resemble heavy industry but arrive in concentrated locations. For our building, assume 24 megawatts of customer capacity. Picture 24 large blocks. Each block can be leased, vacant or under construction. Those blocks are the inventory. At 84% occupancy, 20.16 megawatts are producing rent. The other 3.84 megawatts still exist. Their switchgear must be maintained. Their share of security, insurance and property cost does not disappear. Empty capacity is not like an unsold sandwich that can be removed from tomorrow's order. It is capital embedded in concrete and copper. Public operators illustrate why occupancy matters. Digital Realty reported total portfolio occupancy of about 84.7% at the end of 2025. Equinix reported cabinet utilization of roughly 77%. Those are large diversified portfolios, not promises for a new standalone project, but they show that even major operators do not treat 100% as the normal starting point. One occupancy point in our base model changes annual rent by about $533,000 before ancillary services. 10 empty percentage points remove more than $5 million of rent, while most of the facility remains powered, guarded and financed. So the first economic race is not to complete the building. It is to complete the building at the same time committed customers are ready to occupy it. That race starts with a very large construction bill. Assume the all-in development cost is $10 million per commissioned megawatt. For 24 megawatts, that is $240 million. This is an editorial assumption, not an industry average. Real projects vary widely by market, redundancy, density, land, grid work and procurement timing, but the structure of the bill is consistent. First comes the site, land, permitting, civil work and fiber access, then the electrical chain, utility interconnection, substation, transformers, switchgear, uninterruptible power supplies, batteries and backup generators. Every critical path needs redundancy. Then comes cooling. Traditional server halls may rely heavily on air handling. Higher density AI racks push facilities toward liquid cooling, larger heat rejection equipment and more complex distribution. A change in rack density can alter the mechanical design after contracts have already been signed. Then there is the building itself. Secure walls, raised or slab floors, fire suppression, loading areas, control rooms and multiple fiber entrances. Finally, the owner pays for testing. A data center is not finished when it looks finished. Teams simulate failures, cut utility power, start generators, transfer loads and prove that one failed component does not bring down the whole. In our capital stack, equity contributes $96 million. Permanent debt supplies $144 million. At 6.5% over 20 years, annual debt service is approximately $12.9 million. The lender expects payment whether the building is 60% occupied or 90% occupied, and this creates the lease-up trap. A project can be physically complete, technically excellent and economically painful. If it spends 12 months at 50% occupancy instead of 84, our model loses roughly $18 million of base rent before service revenue. Interest, security, maintenance and staffing continue. The first tenant is therefore valuable for more than rent. A signed lease can unlock financing and justify construction, but it can also create a new risk, building too much around one customer's promise. Wholesale colocation sells large capacity blocks to cloud companies, enterprises and AI infrastructure tenants. The sales process is slow because the customer is not choosing a normal office. It is choosing where critical systems will live for years. That creates attractive contracts. Equinix says its colocation agreements generally run from 1 to 5 years. Large wholesale leases may run longer, especially when the building is designed for a specific tenant. Long contracts make revenue more predictable. They also reduce flexibility. Suppose one customer leases 8 of our 24 megawatts. The building immediately gains a powerful anchor. Lenders see committed cash flow. The owner can build the first phase with confidence. But one contract now represents a third of capacity. Digital Realty reported that its 3 largest customers represented about 26% of annualized recurring revenue at the end of 2025. A single facility can be far more concentrated than a global portfolio. Large customers know this. They negotiate rent, construction allowances, power terms and expansion rights. They may demand reserved adjacent capacity that cannot be sold to anyone else. They may delay deployment after the owner has finished the hall, or they may require a new cooling design for equipment that did not exist when the project began. Smaller retail colocation customers usually pay more per kilowatt. They also require more sales effort, more cabinets, more contracts, more cross-connects and more hands-on support. Wholesale space is operationally simpler but often cheaper. Retail is denser in relationships but more complex. Our model sits between those extremes. A wholesale facility with some interconnection and technical service revenue. We assume those ancillary services equal 7% of base rent. But the largest line moving through the property may not be rent at all. It may be electricity, and treating that line incorrectly can make the business appear far larger or far more profitable than it is. At full load, a 24 megawatt facility can consume electricity on the scale of a small industrial operation. The customer racks draw critical power. Cooling and electrical systems add overhead. The total utility feed must cover both. Many contracts meter customer usage and pass the electricity cost through, sometimes with administrative adjustments. Other contracts bundle a power allowance into rent or expose the operator to changes in efficiency and price. The allocation of this risk matters as much as the headline rate. Imagine the facility collects $30 million from tenants for electricity and sends nearly all of it to the utility. Reporting the $30 million as economic revenue would make the top line look impressive, but it would not create $30 million of owner profit. For clarity, our cash waterfall excludes reimbursed customer electricity. We measure rent and services, then subtract facility expenses that belong to the owner. Efficiency still matters. The industry often tracks power usage effectiveness, total facility energy divided by energy delivered to IT equipment. A perfectly efficient facility would score 1. Real buildings consume additional energy for cooling, conversion and support systems. Improving efficiency can reduce overhead, protect margins and make scarce grid capacity serve more customer equipment. But pushing efficiency too hard cannot compromise uptime. Tenants are not paying for the cheapest possible warehouse. They are paying for continuity. That continuity requires redundancy, extra electrical paths, idle generators, batteries waiting for an outage, pumps that may only be needed when another pump fails, technicians on call at 3 in the morning. Most days, the backup equipment appears economically useless. On the worst day, it becomes the entire product. This is why the facility's cost structure does not fall neatly with occupancy. The empty hall still needs security. The substation still needs inspection. Insurance, property tax and core staffing remain. Now we can finally build the stabilized income statement. Our building has 24,000 rentable kilowatts. At 84% occupancy, 20,160 kilowatts produce rent. Assume monthly rent of $185 per occupied kilowatt. Multiply by 12 months, and base rent is approximately $44.8 million. Add $3.1 million from cross-connects, remote technical support and related services. Revenue excluding electricity pass-through reaches approximately $47.9 million. Now subtract $14 million of facility operating expense. This covers the owner's share of staffing, security, insurance, property cost, routine maintenance and non-reimbursed facility energy. 4-wall EBITDA is roughly $33.9 million. That margin looks extraordinary. It is also not the owner's cut. Generators age. Batteries expire. Cooling systems require major work. Switchgear cannot be ignored because it still turns on. We reserve $8 million a year for lifecycle capital and future refreshes. Then the lender takes approximately $12.9 million in annual debt service. $33.9 million of EBITDA becomes about $13 million of illustrative pre-tax owner cash, against $96 million of original equity. That is a cash yield of about 13.5% at stabilization. The phrase at stabilization is doing enormous work. It excludes the years of development risk. It assumes the project reaches 84% occupancy. It assumes the rent level holds. It assumes the owner controls construction cost and reserves enough for replacements. It assumes no major outage destroys customer trust. The model also excludes taxes, corporate overhead, development fees, land appreciation and refinancing. It is not a promised return and it is not a public company's reported free cash flow, but it gives us a reconciled base case. And once the bridge is reconciled, we can change two inputs and watch the owner's cut disappear. In the weak case, Occupancy falls to 62% and rent falls to $155 per kilowatt per month. Revenue excluding reimbursed power drops to about $29.1 million. Operating expenses remain $14 million because the facility cannot remove half a substation or guard only the occupied cabinets. EBITDA is still positive at roughly $15.1 million. A headline might call that a profitable data center. After the same $8 million lifecycle reserve and $12.9 million of debt service, owner cash is negative by approximately $5.9 million. The owner must add cash even though the building reports positive EBITDA. Now take the strong case. Occupancy reaches 94%. Rent rises to $215 per kilowatt per month. Services reach 9% of rent. Revenue becomes about $63.4 million. After operating expense, reserve and debt, illustrative owner cash reaches roughly $28.5 million. The same shell moves from consuming almost $6 million to producing more than $28 million. This is the operating leverage of a capital-intensive subscription business. Once the fixed system exists, the next leased megawatt can carry a high incremental margin. But until it is leased, that megawatt is a silent machine financed with very loud debt. Pricing matters almost as much as occupancy. At 84% utilization, a $10 change in monthly rent per kilowatt moves annual base rent by about $2.4 million. The owner cannot solve this only by negotiating harder. Pricing depends on local power scarcity, customer concentration, competing supply, contract length, network connectivity and the cost of moving workloads elsewhere. The best facilities therefore develop a moat that is deeper than concrete. A warehouse can often be replaced by another warehouse. A mature data center is harder to copy. First, it has energized capacity. The utility work, permits and equipment are already complete. In a constrained market, a customer may value delivery next quarter more than a lower price at a site that will not receive power for 3 years. Second, it has operating history. Customers can examine uptime, maintenance procedures and incident response. Reliability becomes evidence rather than a construction promise. Third, it has connectivity. Multiple carriers, cloud on-ramps and existing cross-connects make the facility more useful as more customers join. Moving a rack is possible. Rebuilding an entire web of network relationships is harder. Fourth, it has expansion options. A customer that grows from 2 megawatts to 4 would rather expand next door than migrate everything. But the owner must reserve capacity carefully. Holding space for a customer who never grows can block another lease. Finally, it has trust. A data center is a landlord whose failure can interrupt its tenant's business. That makes reputation part of the physical asset. These advantages explain why public operators emphasize recurring revenue and customer relationships. Equinix reported more than 90% of revenue from recurring streams. That does not make the cash risk-free. It means the product becomes stickier after the facility proves itself. The strongest owner therefore manages 2 clocks. The first is the development clock, how quickly cash becomes commissioned capacity. The second is the lease-up clock, how quickly commissioned capacity becomes contracted rent. Building faster than the grid creates an empty shell. Leasing faster than construction risks disappointing customers. The value lies in synchronizing the two. And that brings us back to the original question. What does the owner really keep? Our illustrative owner begins with a 24 megawatt facility costing $240 million. $96 million comes from equity and $144 million from debt. At 84% occupancy and $185 per occupied kilowatt per month, the facility produces approximately $47.9 million of annual rent and service revenue, excluding reimbursed customer electricity. Four-wall EBITDA is about $33.9 million. After an $8 million lifecycle reserve and approximately $12.9 million of debt service, the illustrative pre-tax owner's cut is roughly $13 million. That is the base answer, not the opening year, not an industry average and not a guarantee. In the weak scenario, lower rent and 62% occupancy turn that $13 million surplus into a cash deficit near $6 million. In the strong scenario, high occupancy and stronger pricing lift owner cash above $28 million. The business is often described as digital infrastructure. Economically, it is a contract wrapped around an electrical system, sitting on real estate, financed like a long-lived asset and judged every second like a technology service. The server may create the intelligence. The building creates continuity. And in an AI boom, the most valuable thing the owner can sell may not be a chip, a model or a cloud. It may be one energized megawatt, available on the date the customer actually needs it.